Alright guys, today in class we learned about the law of definite proportions and the law of multiple proportions. The problems in the black boxes here are the ones that we did during class. So in this first one it says a pure sample of sodium fluoride contains 35 grams of sodium. How many grams of fluorine are present? So if we write out our given information, it says that 35 grams of sodium is equal to how many grams of fluorine. So what we're looking for is how much fluorine is present. And what we know is the ratio of sodium to fluorine because we have the formula. So if we know that we have this much sodium and we know the ratio, we can solve for the amount of fluorine present. The way we quantify this compound formula is we're going to take our periodic table and we will look for sodium. And if you look on group 1, in group 1 of your periodic table, you see sodium is about 22.99, so I'm just going to round it to 23 grams. So 23 grams of sodium. Because there's one part, I don't have to multiply anything, it's just times 1, is equal to 1 part fluorine. So again, look at the periodic table. Fluorine is found in group 17. We see that it's approximately 19, so I'm just going to round 18.998 to 19. So is equal to 19 grams of fluorine. Now what we're going to do is we're just going to take this information and use it as our given, and this is our desired outcome, and this is called our conversion factor. Again, remember, we can take any equality statement and write it out as a conversion factor. So we start with 35 grams of sodium and we want to get 2 grams of fluorine. I'm going to take it times the conversion factor. Remember, when we have a conversion factor, this is technically over 1, so we want to put sodium on the bottom. So here is my sodium component. It is 23 grams of sodium. And then I want to put the one I want to get to on top, so that's what's left behind. So 19 grams of fluorine. Now because I have sodium on top and sodium on bottom, that crosses off. But mathematically, I need to take 35, and you'll multiply by the number that's on the top of that, so times 19. And then you'll divide by the number that's on the bottom. Now, I am only given 2 sig figs with the 35 grams of sodium, so I'm going to round this to 2 sig figs, and I get 29 grams of fluorine. Now we're going to move on to the next one here. Feel free to pause the video if you want to try set it up yourself first. It says if there are 42 grams of hydrogen, so that's my given quantity, what I'm starting with, and my compound is methane, which is CH4, how many grams of carbon? So I want to know how much carbon if I know how much hydrogen I have. So we're going to use this formula to make an equality statement. If you find carbon on the periodic table, you'll see it's approximately 12 grams of carbon in one part of it. If you have 4 parts hydrogen, you'll take the 1 gram times 4 and get 4 grams of hydrogen. So here's my equality statement that I'm going to put into a conversion factor where I put hydrogen on the bottom. So 4 grams of hydrogen and 12 grams of carbon. Grams of hydrogen, 1 on top, 1 on bottom. Now I'm going to take 42 times 12 divided by 4. And I get 126, but my given only gives me 2 sig figs. So I go 1, 2, look to the right, and I'm going to round up to 130. So 130 grams of carbon. If you're watching the video, they do not do sig figs. So do not listen to the video for the sig figs. Alright, if there are 19 grams, again pause if you want to try set it up yourself, of oxygen, in a sample of aluminum oxide. So there's 2 parts aluminum to 3 parts oxygen. We want to know how much aluminum is present. So what we're going to do is we are going to take the aluminum's mass on the periodic table times 2, and I get a mass of 54 grams of aluminum is equal to 48 grams of oxygen. Now I'm going to take it times the conversion factor utilizing this equality statement, knowing that I want oxygen on bottom. So 48 grams of oxygen is equal to 54 grams of aluminum. Grams of oxygen cross off. On my calculator, I'm going to take 19 times 54 divided by 48. And with 2 sig figs, I'm going to get 21 grams of aluminum. Alright, here are some extra problems. Pause the screen now and try these problems. That would give us 35 grams of fluorine. Again, we've got our conversion factor, courtesy of looking at our periodic table, to find that sodium on the periodic table has a mass of approximately 23 grams, if you have 1 part of it, and fluorine about 19. So we're going to put the sodium on bottom so it crosses off, fluorine on top. I'm going to change pens here, it's driving me crazy. This one is dying on me. Problem. Our given quantity, 19 grams of fluorine. Oh, I don't know, I was going to spell the whole word for some reason there. Our conversion factor is going to use the same from the previous, because we still have 1 part sodium to 1 part fluorine. So this time, however, I start with fluorine and I want to get to sodium. So this time I want fluorine on bottom. So I'm going to put 19 grams. Oh my goodness, I magically ended up with 19 grams. Alright, 19 grams of fluorine is equal to 23 grams of sodium. This one's going to be silly because the 19 also crosses off. And that, even if you took 19 divided by 23, or sorry, times 23 divided by 19, you're obviously going to get 23 grams of sodium. I just picked random numbers. Silly goose. Alright, let's go ahead and do the next one. This time our given quantity is 61 grams of oxygen. And I'm going to take it times the conversion factor that relates the 2 parts aluminum to the 3 parts oxygen. And I did that up here in a previous step, so I'm just going to record that 54 grams of aluminum is equal to 48 grams of oxygen. Now I'm going to want the oxygen on bottom, so I'm going to write 48 grams of oxygen. Again, because it's on top here, I have to put it on bottom there. And then I'm going to put the 54 grams of aluminum on top. Grams of oxygen cross off. I'm going to take 61 times 54 divided by 48. That is going to give me 69 grams of aluminum. Alright, there are some problems practicing the law of definite proportions.